Let's solve this interesting Olympiad equation together. It says x raised to power y minus y raised to power x is equal to 17. We are about to solve for x and y in this question. Okay. Now, first thing we can do here is to say that let's outline the law of indices. The law of indices we're going to use here is the law that says that a raised to power m, okay, all raised to the power of n, it's equal to a raised to power n, all raised to the power of m, which is equal to a raised to power m multiplied by n. Okay. Now, secondly, we can say that x raised to power y can be expressed as x raised to power y multiplied by 2 over 2. 2 over 2 is 1. Okay, we are basically not multiplying by anything. Now, this is minus y raised to power x multiplied by 2 over 2. Again, 2 over 2 is 1. This is equal to 17. Now, you can agree with me that from this law I outlined here, we can change this to, okay, so you can say that this is x raised to power y times 1 over 2 times 2. Okay, so this is y over 2 multiplied by 2 minus y raised to power x over 2 multiplied by 2. Okay, it's equal to 17 from the law of indices I've used here. Now, again, from here, you can now say let's isolate this. So we have that x raised to power y over 2 can be said to be raised to power 2 minus y raised to power x over 2 raised to the power of 2 is equal to 17. Again, this follows from the law of indices. If you look here, a raised to power m raised to power n is equal to a raised to power m multiplied by n. So the same thing we did here, this times this can be written as this raised to power of this. Okay. Now, moving on from here, you have seen that you have difference of two squares. We can now go ahead and say that a is equal to x raised to power y over 2 and b is equal to y raised to power x over 2. Okay, so let's now move on from here. So we can now write the expression as a squared minus b squared, okay, is equal to 17. Now we're going to have from here that this is equal to a plus b multiplied by a minus b from factorizing this to be equal to 17. Okay. Now, the only multiple of 17, because 17 is a prime number, the only multiple of 17 is 1 and itself. Okay. Now, having established this, we can now say, given that a and b are whole numbers, okay, positive whole numbers. Now, this means that when you add positive whole numbers, it's always greater than when you subtract positive whole numbers. Okay, the same number. Now, this means that you're going to have that a plus b should be greater than a minus b, meaning that a plus b from here should be 17, and a minus b is equal to 1. Alright? Now, let's add these two equations and see what we get. We have 2a is equal to 18. Okay, from here we have that a is equal to 9, comma. From here now, knowing our a is equal to 9, our b should be equal to 8. Okay, now let's go ahead and resubstitute these for a and b. So we have that our a is equal to x raised to power y over 2, and this is equal to 9. Okay, and our b is equal to y raised to power x over 2, and this is equal to 8. Okay, now looking closely here, we can say that let's raise both sides to the power of 2. Okay, so if you raise sides to the power of 2, you see that 2 will cancel 2, and this will become 9 squared. The same thing, if you raise both sides to the power of 2, you see that the same 2 will cancel 2, and this will become 8 squared. Okay, now moving on from here, we can express 9 as 3 squared. Okay, so how about our x raised to power y is equal to 3 squared raised to the power of 2. Okay, and from the law we introduced in the beginning from indices, you can multiply these two terms. So we have 2 times 2 is 4, so this becomes 3 raised to the power of 4. Okay, so we can conclude here that our x raised to power y is equal to 3 raised to the power of 4. Furthermore, for this here, you can have that y raised to the power of x will be equal to, so for our y raised to the power x, okay, we can say that 8 is 4 times 2, okay. So from here, we're going to have that this is equal to 4 squared times 2 squared, okay. Then y raised to the power of x can be said to be equal to 4 squared multiplied by 2 squared is 4. When the bases are the same, you add the power. So this is 4 raised to the power 1. 2 plus 1 is 3, okay. So we have 4 raised to the power 3 to be equal to y raised to the power of x. Now, let's call this equation 1 and call this equation 2. If you compare these two equations, you see x raised to the power y is 3 raised to the power 4 and y raised to the power x is 4 raised to the power 3. What does this tell us? If you compare, when you see y, you see 4, y 4, x 3, x 3. It means that our x is equal to 3 and our y is equal to 4. Okay? This is our answer for this question. But now let's test our answer to confirm if it's true. Let's substitute x as 3. So we have 3 raised to the power y as 4 raised to the power 4 minus, we have again y as 4, we have 4, and x as 3, we have 3. It's equal to question mark. Okay? 3 raised to the power 4 is 81 minus 4 raised to the power 3 is 64. 81 minus 64 is equal to 17. Okay? So this becomes the correct answer for this question. Thanks for watching.
What's going on, guys? It's watching here editing this video. As you can see, about 99% of you guys are not subscribed to the channel, so please subscribe, like, comment, and share my videos, as this helps to push my videos out to more viewers out there. The more you subscribe, the more viewers can see my videos, the more we grow in this community. Thanks for watching, and I'll see you guys in my next video.